Let's talk about Lewis dot symbols and make it simple. So this is a pretty simple topic. We're going to get through this real quick. So let's jump right in. What are we doing when we're making a Lewis dot symbol? We're taking an element from the A groups. So like group 1A, 2A, and then 3 through 8A. We're writing the element symbol, and then we're just showing how many valence electrons it has as dots on the outside of the symbol. So remember that the A group numbers is the number of valence electrons that the entire group has. And a group is a column, right? So in other words, hydrogen and potassium, rubidium, those are all in group 1A. So they all have one valence electron. Now, some of these elements, like everything below hydrogen, they have more electrons. But remember, the valence electrons are those in the outermost shell. So the outermost shell has one electron here. Group 2A has 2 valence electrons. 3 has 3. And as we keep going on, okay? So the A number group columns are how many valence electrons they have. So let's just do an example. We are going to take the symbol for an element, and we're going to draw it down. So let's do just hydrogen for an example. We have the element symbol, and it's in group 1A, so it only has 1 valence electron. We just draw it on top as a dot. That's it. And if I wanted to do it for any of the other elements in group 1A, I would just switch out the symbol for, K for potassium, and it would have the same Lewis dot symbol. Now, if I went to group 2, now I'm going to have 2 dots. And same for, as we go on, the same pattern. Let's do something like nitrogen, though, which is in group 5A. And to see the pattern, we always start at the top, and then we go clockwise with 1 electron on each side until we have to double up. So for 5 electrons, we're going to go 1, 2, 3, 4, 5. And I always like to draw each electron a little bit askew so that if I have to double up, then they're kind of centered together, right? It's not a big deal, but just a little tip to make it look good. So that's the Lewis dot symbol for nitrogen. And let's do something with more electrons like fluorine, which is in group 7A. So it has 7 valence electrons. And let's actually do it for iodine, because it's also in group 7A, and it doesn't make a difference, right? The Lewis symbol, the dot symbol, is going to be the same. We just replace the element with the other element. If they're in the same group, they're going to have the same dot structure around it, okay? So let's do iodine, and this could have been bromine, it could have been chlorine, but it's in group 7, so I go 1, 2, 3, 4, 5, 6, 7. And so as we can see, there is 1 unpaired electron in the Lewis dot symbol for iodine. And this is the question that they could ask. So if you look at nitrogen, and the question is, how many unpaired electrons does nitrogen have in its Lewis dot symbol? You could say that there's 1, 2, 3. Because when you have 2 dots together, we call that a lone pair, okay? So another question they could say is, how many lone pairs does, it is on the Lewis dot symbol for iodine? And you say, okay, well, there's 1 unpaired electron, but then there's 1, 2, 3 pairs of electrons. So it's 3 lone pairs is how we phrase that. And that's it. But there is one exception that I'm going to get to in just a moment. Guys, if these videos help you, please give a like, follow, share, save this so you can review it later. And if you'd like to check out and support me further over here, you can patronize me there. That helps me to keep going and make these videos for free. Now, the one exception is helium. It is number 2 on the periodic table, which means it has 2 protons, and if it's neutral, which it normally is, it also has 2 electrons. Now, it's in group 8A, so basically all the noble gases have 8 valence electrons because they're in group 8A, but helium, it only has 2 electrons. So it only has 2 valence electrons because there are only 2 electrons, right? So if you were doing helium, just make sure that you don't look at the group number and blindly just put 8. It's only 2, so you would draw a structure like this. And so some periodic tables will put helium both in this location and also this location because it has 2 valence electrons, so being in group 2A makes sense, but it's a noble gas, so they put it in group 8A because that also makes sense, right? So I've seen a couple periodic tables that have it in both locations before. It's not typical, but just remember that exception. So if you do the Lewis dot symbol for helium, it only has 2 electrons, 2 valence electrons, and that's it. All right, guys? So again, if this helped, please do all the, favorable things for the algorithm, and please support me. You can consider that. I appreciate it, and I'll see you guys in the next video.